Welcome, dear children, to today's topic. Today, we are discussing kinematic equations of motion. So, these are the equations of motion which you have studied in 9th standard. The same step, the graphical method, we are following. Okay, the appearance of the equations slightly different. It's not like S is equal to ut plus half a t square, not like that. Notations are little bit different. So let's discuss. Okay, so first we consider an object in uniformly accelerated motion. For such a body, you have the velocity time graph as shown. So from the graph, you can see it is having positive acceleration because the slope is positive. Now, what all things we can, in what ways we can characterize the motion of that body? See, here the point A, B is the graph. The point A on the y-axis, it denotes what? The velocity of the object at time t equal to 0. That's what we call as initial velocity. So, V0 is the initial velocity. So, instead of U, what we took in 9th standard, here we are taking V0, that is the initial velocity. Now, at B, its velocity is V. Okay, so that V is what? Final velocity. At time t, its velocity is V. So that V is called final velocity. And the letter A we use to denote acceleration. And x0, what is x0? x0 is the initial position. And x is the final position, means at time t, what is the position? So x and V are final position and final velocity. Then x0 and v0 are the initial position and initial velocity. Okay. Now t is the time of motion for which we consider. Okay. Now we are going to derive the expressions, the equations of motion, and equations of motion were derived by Sir Isaac Newton himself. Okay, let's see what is the first equation of motion. First equation of motion, we start with the point that slope of velocity time graph gives acceleration. Okay, so this graph slope, what will be the slope of this graph? Actually, this comes as that angle theta, you know. So tan theta. So we don't need to write that tan theta here. But here the slope is what? BC by AC. Tan theta is BC by AC. Okay. So we have slope is equal to A, that is acceleration, that is equal to BC by AC. Now what is this BC? I said B is V. Okay. So this BD distance is V, and up to this point, that means up to the point C, it is V0. So BC becomes V, that means BD minus CD. BD is V and CD is what? V0. So it is V minus V0. So what is BC? BC is V minus V0. So we have BC, V minus V0. Now what is AC? AC is the same as OD. OD is what? OD is T. So we have V minus V0 by T. So rearranging, we have AT equal to V minus V0, or V is equal to V0 plus AT. And this equation is called as first equation of motion, or it is also called as velocity time relation. So very important, the name you should know, velocity time relation. So this equation is called velocity time relation, which is V is equal to V0 plus AT. You have already studied this equation in the form V is equal to U plus AT. Now you study in this form, that is more better. Okay, so V is equal to V0 plus AT. Now for deriving the second equation, we use the concept that area under velocity time graph gives displacement. Okay, area under velocity time graph gives displacement. Here AB is the graph. Area under the graph means what? This is the area actually. Okay, so it comes as the area of this triangle ABC and area of rectangle OACD. So area under the graph AB means area of triangle ABC and area of rectangle OACD. And here what is the displacement? We said x is the final position and x0 is the initial position. So x minus x0 comes as the displacement. Displacement is x minus x0. So we derive the expression for that means second equation of motion. So x minus x0 is equal to area of rectangle OACD plus area of triangle ABC. Now what is area of rectangle OACD? You know, area of rectangle, it is just length into breadth. So we have OA into OD. It is OA into OD, that is area of rectangle. Now area of triangle is what? Half BH is the expression for area of triangle. So half into base is what? AC into H is what? BC. So half into AC into BC will be the expression for area of triangle. So OA into OD plus half into AC into BC. Now you know OA is what? V0. From the graph we have V0 and OD is T. So we have V0 into T plus half into AC. AC is the same as OD. From the figure, AC is the same as OD. So half into T into BC, we already said it is V minus V0. Now rearranging the equation. So here we have a term V minus V0. For that term, we substitute from first equation. First equation is V is equal to V0 plus AT. So what is V minus V0? It is AT. So in this equation, substitute for V minus V0. So we have AT. So we have the equation x minus x0 equal to V0t plus half into t into AT. So our expression becomes x minus x0 equal to V0t plus half AT square. So this is the second equation of motion, also called as position time relation. So don't forget the different names. The first equation is also called as what? Velocity time relation. The second equation is called as position time relation. In deriving third equation, we use the same concept as I said earlier. Area under the graph gives displacement. In the previous case, we took the area as the sum of rectangles area and triangles area. Here we consider what? The trapezium as a whole. So area under the graph AB means area of the trapezium OABD. Area of trapezium OABD. Now you know what is area of trapezium. Area of trapezium means half into H into A plus B. What are A and B? A and B are the lengths of the parallel sides. Here parallel sides are OA and BD. Okay. So OA is V0 and BD is V. Now what is H? The separation between the two parallel sides of the trapezium is termed as H. So what I said, the expression for area is half H into A plus B. Here, half H into A plus B. So here A and B are the length of the two parallel sides. V and V0 will get. And H is what? H is the separation between the two parallel sides. So we have here H, we will have OD. OD is coming as H. So the expression becomes x minus x0 equal to half into OD into OA plus DB. OA is V0 and DB is V. So we have half into T into V0 plus V. Okay. Now from first equation we know v minus v0 equal to at, or t is equal to v minus v0 by a. So in this equation it is for this t we substitute. So we have half into v minus v0 by a into v plus v0. So v minus v0 into v plus v0, it's just like a plus b into a minus b. So it becomes v square minus v0 square by 2a. So rearranging, we have 2a into x minus x0 equal to v square minus v0 square. So the final expression we have v square is equal to v0 square plus 2a into x minus x0. Okay, and this equation is called third equation of motion, and it is also called as position velocity relation. So take care, this is the equation which is independent of time. The other two equations have the t term in that equation, so they are dependent on time, and this equation is independent of time. So the three equations of motion we have discussed. That is, first one is v is equal to v0 plus at, and second one is x minus x0 equal to v0t plus half at square, and the third one v square equal to v0 square plus 2a into x minus x0. Okay, so the derivation as such is very important. It will come as a 5-mark question for descriptive exams. Okay, and it may come as a 3-mark question, just like derivation of second equation of motion or third equation of motion separately as a 3-mark question. That like that also it will come. So it is very important to draw that graph. The graph you have to draw, from the graph only you need to explain. Now we are going to do problems. So before discussing problems, we have to discuss the sign convention which we follow. Okay, so it is usual means in these problems that the objects moving in one dimension motion, mainly we will be considering upward motion, downward motion, like that. So all the physical quantities in upward direction, we take them to be positive. Okay, and all the physical quantities which come in downward direction, we will take them to be negative. So what is an example? When a stone is thrown upwards, its initial velocity is in upward direction. So that initial velocity we will take it as positive. So all physical quantities which comes in upward direction, we will take them to be positive. Okay, when a stone is thrown downward, its initial velocity is in downward direction. So we will take that initial velocity to be negative. So it is as per the question, we need to apply the sign. So applying sign is very important. Okay, now very important thing. See, when an object moves in vertical direction, the acceleration of the body will be acceleration due to gravity. Whether it is going up or down, that body has an acceleration called acceleration due to gravity. You know, this acceleration due to gravity is the same for all objects irrespective of its mass. And it was found out by a scientist, Galileo. From Leaning Tower of Pisa, he conducted an experiment, and as the conclusion, we'll be mentioning about it later. Okay, so as a conclusion, he stated for all objects the acceleration is this 9.8 meter per second square, that is acceleration due to gravity. Okay, and it is acting in which direction? Downward direction. So always for all bodies, irrespective of its mass, shape and all, the acceleration due to gravity is the same and it is acting in downward direction. Okay, so in such problems, when we take that acceleration, we will write a is equal to minus g. See, g is a positive value, that is 9.8 meter per second square. That acceleration we take as minus g, so that is minus 9.8 meter per second square. Usually in problems, they will give in questions to take g as 10. So we will write as minus 10 meter per second square. Okay, so this is how we have to apply sign convention. In horizontal direction, that means on the road and all? No, that forward direction we will take as positive and backward direction we will take as negative. In what direction the buses or the vehicles are going or objects are going, that forward direction we will take as positive and backward direction we will take as negative.
Now we will do one problem, that is example 3-4. A ball is thrown vertically upwards with a velocity of 20 meters per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground. How high will the ball rise and how long will it be before the ball hits the ground? So when we read this question, some sign convention we already discussed. Once again I am explaining that sign convention what we are following. So when we use this equations of motion in solving problems, we have to apply the sign convention. That is the direction. That means here the motion is in up and down direction. So we will take the upward direction to be positive. That means all the physical quantities which come in upward direction, that we will take as positive, and the which one come in downward direction we take it as negative. Okay. Now when the ball is thrown vertically upwards with a velocity 20 meter per second. So that 20 meter per second is the initial velocity of the ball. So that initial velocity V0, it is in upward direction, so it is positive. Now height of the point from where the ball is thrown is 25 meter from the ground, means x0 equal to 25 meter. How high the ball will rise? You are asked to find the vertical displacement of the ball. Okay, and it's given g is equal to 10 meter per second. Here g stands for what? When the ball is rising up, there is what? Acceleration. That acceleration is due to the gravitational force of earth, and because of that we call that acceleration as acceleration due to gravity. So the acceleration of the stone which is going up is acceleration due to gravity, and it is always acting in downward direction, and you are supposed to take the value of g as 10 meter per second square. So when we write acceleration a is equal to what? Minus g. A is equal to minus g or minus 10 meter per second square. Okay, you are asked to find to what height it rise. So as I was mentioning in the previous classes, when a stone is thrown upward, it rises to a height, means it reaches a maximum height. Suppose this is the maximum height position, then thereafter it comes down. That's what is happening with any object which is thrown upward. So what is the speciality of this maximum height position? At that position its velocity is becoming 0. That is the peculiarity. At that position velocity is equal to 0. So here you are asked to find the height reached by the stone. So we are considering only the upward motion of the stone. So first we consider only the upward motion of the stone. So for the upward motion, these data we can write, that is initial velocity is plus 20 meter per second. Acceleration is minus g, that is minus 10 meter per second square, and final velocity is 0 meter per second. So to find that height to which it rises, which equation we can use? The third equation, which is not having that time dependence. So v square equal to v0 square plus 2a into, instead of x minus x0 they wrote y minus y0, since it is moving in y direction. Okay, so by substituting we have y minus y0 equal to 20. So what is y equal to 20 plus y0? That is, what is 20 plus y0? That initial position is at 25 meter from the ground. So from the ground this stone reaches a height 45 meter. From the top of the multi-story building, the stone goes to a height 20 meter, but from the ground it goes to a height 20 plus 25, that is 45 meter. Okay, hope it is clear. Now going to the second part. What was the second part of the question? It is how long will it be before the ball hits the ground? You're asked to find what time the ball takes to hit the ground. Okay, so to complete that motion, how much time it takes? So for the second part, we can consider the motion of the stone as a whole. So it starts from a height 25 meter, travels 20 meter additional to means upward direction, then it falls down and reaches ground. For this motion, you need to find the time taken. I repeat, from the top of the building, suppose this is the building, from the top of the building, the ball goes up, then from there it falls down. Okay, so for the whole motion, we need to find the time taken. So which equation we can use is that second equation, x minus x0 equal to v0 t plus half t square. In that t we need to find. What about the other terms? V0 we know that is 20 meter per second. A is minus g, that is minus 10 meter per second square. What about that y and y0 or x and x0? X0 is what, or Y0 is 25 meter because it is thrown from the top of the multi-story building which is at a height 25 meter. Okay, and Y, finally where goes this stone, where does it reach? It reaches the ground. Okay, so that final position becomes what? 0 meter. That is a point to be noted. Okay, so at the end of the motion, the stone reaches the ground and its that position is what? 0. Okay, now we got everything for that second equation. Just to substitute in that equation and we will get the time. So here we are getting one quadratic equation. Solving that quadratic equation, we will get time t is equal to 5 seconds. So time taken by the stone to reach ground, it is 5 seconds. So with that, we conclude today's session. Thank you.